Today, we want to go into more detail about why reference angles work the way they do and why certain things are positive, where they're positive, and other trig functions are negative. So if you would recall, sine of theta gave us a positive value in quadrant 1 and quadrant 2. Cosine theta was positive in quadrant 1 and quadrant 4. Tangent was positive in quadrant 1 and quadrant 3. Sine is positive in quadrant 1 and quadrant 2 because that is where y is positive. So if we think about the y coordinates, quadrant 1 and quadrant 2 are where y is positive. So sine is positive in quadrant 1 and quadrant 2 because y is positive in quadrant 1 and quadrant 2. The x-axis is where y is equal to 0. And if we go up from there, we have positive y value. So sine is negative in quadrant 3 and 4 because the y coordinates are negative in quadrant 3 and 4. So in quadrant 1, y is positive. In quadrant 2, y is positive. In quadrant 3, y is negative. And in quadrant 4, y is negative. The other one we have is that cosine is positive in quadrant 1 and quadrant 4. If sine is going to be all about the y's, then cosine is going to be all about the x's. Math is very predictable like that. So cosine is positive in quadrant 1 and quadrant 4 because x is positive in quadrant 1 and quadrant 4. So x is positive here on the right side of the y-axis. X is negative on the left side of the y-axis. So here in quadrant 1, x is positive. Here in quadrant 2, x is negative. Here in quadrant 3, x is negative. And in quadrant 4, x is back to being positive. Because here's 0, and x counts up this way, 1, 2, 3, 4, and so on. Tangent is positive in quadrant 1 and quadrant 3. This is where x and y have the same sign. If we divide things with the same sign, we get a positive value. So quadrant 1 and quadrant 3, this is where x and y have the same sign. So tangent is going to be positive when x and y have the same sign. This is a very popular observation, so well done. Sine is tied to the y coordinates, cosine is tied to the x coordinates. And tangent is positive when x and y are the same. Because positive divided by positive is positive. Negative divided by negative is positive. How's everybody okay? We do need to connect these coordinates, x and y coordinates, more closely to sines and cosine. X for cosine and y for sine. So let's draw a triangle, a right triangle, with theta in standard position. So if we draw a triangle in standard position, where 0 degrees here is down here on the positive x-axis. Let's draw theta in standard position, where 0 degrees is the positive x-axis. Now let's just start with an angle in the first quadrant. Here's a right triangle with the angle theta. Notice that the radius of the circle is going to be our hypotenuse. So the hypotenuse is the radius of the circle. The side opposite the angle theta is going to be the is going to be on the y coordinate of the circle. If we think at this point on the circle, x and y coordinates, the opposite is a vertical distance, so it's the y coordinate, and the adjacent side is the x coordinate. Opposite over hypotenuse is sine of theta. So that's what's connecting the sine to the y coordinate. Cosine theta is adjacent over hypotenuse, and that's a connection between cosine and the x coordinate. So going around this circle, the x coordinate will tell us the cosine of theta. The y coordinate will tell us the sine of theta. The way that we want to use this is to think about what's going on in what we call the unit circle. Unit circle means the radius is 1. The hypotenuse is the radius, so the unit circle, the hypotenuse is always 1. Is the picture a little wavy? Is it going like it's hot? It's like the projector saying, "Ooh, it's hot outside. I better make it look like it's hot outside on the screen." So it's like, "Oh, I'll put the hot effect on." I'm like, "Oh, don't do that. Make a cold effect so we can start feeling cold." I was just worried that I was the only one seeing it, which could be happening. If you weren't seeing it before, but you are seeing it now, sorry. That's on me. That's my fault. Let's take this angle theta and flip it around until we get a theta degree reference angle in the second quadrant. So imagine this point starting off at 0. We go up to theta. We keep on going, and I'll get a copy of this right triangle. I'll have that same right triangle, but the mirror image in the second quadrant. So let's draw that mirror image triangle in the second quadrant. That will be this angle theta. So if I keep going around, keep my angle start off at 0, go up to theta, and I keep going, eventually I'll get a copy of this right triangle in the second quadrant. You get this mirror image. And I'm going to put theta sub r as a reference angle. just from a side length standpoint, here the adjacent is going to be the same, but notice that the adjacent is going in the negative x direction. Adjacent is associated with cosine. The x is negative here, so the cosine is going to be negative. The opposite is associated with the y. And in the second quadrant, y is positive, so opposite is positive, so sine is positive. Hypotenuse on the circle is just always the radius. So the reason that the reference angle gives us the same absolute value is that the reference angle is making a copy of our original triangles. It's making a copy of that triangle in the second, third, or fourth quadrants. Any questions? So that's why we have the same values. It's just that here, the x is going to be a negative and the y is positive. Any questions? How's everybody okay? This building has like an environmental award. There's like a big old plaque out there, which means it doesn't have air conditioning. I realize environmentally this is a good idea, and we rarely need it. We would rarely need it anyway. It'd be crazy to say, I'm building a building in San Bruno. Oh, well, we should put some air conditioning. It's like, well, no, it's going in San Bruno. And they're like, oh, don't forget about climate change. You're right. Let's speed that up and put air conditioning in the building. Fast forward to my house where I barely have insulation, which is fine if it's nice and temperate, but when it's hot in the house. And when it's cold in the house. Any questions? We can follow this all the way around. If I draw this same right triangle flipped down into the fourth quadrant, I would have the same lengths, opposite and adjacent and hypotenuse. But in that case, the y would be negative. The x would be back to being positive. So if I drop this down into the fourth quadrant, we see that the x is positive and the y is negative. So the other way to think about it is the sine is associated with opposite, cosine is associated with adjacent, and this connects with how we make reference angles. This is why reference angles are always connected to the nearest part of the x-axis, because that's where those triangles are going to show up. That's where the reflections and the flips of these triangles are going to show up. Any questions? Comments? Deep thoughts? How's everybody okay? Overheating? But we don't want to think too hard. That could cause overheating. Everybody make sure you hydrate. There are some angles that we just need to know. There are some angles that we're going to have to recognize. And we're going to have to know the trig values of all these angles. And we're going to have to know these trig values in all four quadrants. So here's the stuff that we want to know. We are going to want to know sine, cosine, and tangent of angles with a 30, 45, or 60-degree reference angle in all four quadrants. We're going to want to know sine, cosine, and tangent of any angle with a 30, 45, or 60-degree reference angle in all four quadrants. We're also going to want to know sine, cosine, and tangent of any angle that lands on a quadrant, quadrantal angles. So those are the ones that are dividing up the quadrants. So 0, 90, 180, 270, 360 is the same as 0. We want to be familiar with these values going all the way around the circle. We only have to go around once, because if I have a 720-degree angle, that's at the same place as the 0 or a 360. And if we know 0, we know 360. We'll also know 720. We'll also know negative 360. We just got to know going around once. But here are all the values that we have to know. Pause for copy. Oh, I'm not supposed to say that part. Pause for copying means take a sip of coffee. I don't have coffee, so I have water. In the old days of fancy professors, I'd be standing up here with like a pipe, but I also would have like a tweed jacket on, you know, with like the patches on the elbows. And I'd have like a tweed jacket and like a vest, or I'd call it a waistcoat, and like pants. I'd have like wire rim glasses, and I'd have a pipe, and I would be smoking it during class. And instead of just like corporate paneling, it would have like fancy wood paneling all the way around. And the room would smell really bad. And I'd probably have a fancier sounding book. But I'd have a pipe in my hand. So we want to know the sine, cosine, and tangent of angles with a 30, 45, and 60-degree reference angle in all four quadrants. And then for emphasis, rather than taking a sip of coffee, I would smoke the pipe. Then I would say, are there any questions? And then you would know that you're not supposed to ask questions. You're just supposed to be there. You know what I mean? We've adapted this rule to American high school. I don't know if you've been in American high school before. But what is the single most important thing to do? The single most important characteristic to have when you're a high school student? Anyone know what it is? What's that? No, that's the worst. That demonstrates curiosity. That's not most important. It's not being smart. Being there is number one most important, is number two most important. Most important is once you're there, actually it's number one most important, but number two, at the same time, is being quiet. Just be compliant. Stay under the radar. Don't ask questions. Kind of like cruise through. Anyway, that's just been my experience. I don't know if that's true or not. Anyway, what are we talking about? That's also the impression that I get when I come in. There's a lot of times students come in and they're just like, oh, just gonna walk into the math class, sit down, not get noticed, wait for him to go in a wrap-up voice, pack up my shit and go. You know what I mean? What I'm saying is a very lonely job, which is why I get on tangents so often. Not like sine cosine tangents. Like take a break from talking about math to talk about other stuff while you're copying things down. Okay. How's everybody okay? Anyway. Let's learn our angles. Here's how we want to go about. I have to make a circle. I don't know if I want to use the thing to draw the circle because it takes so much longer. Here's going to be the center. If I had been ready for today, if today I knew was a Tuesday and not a Monday like I thought it was in the beginning of the day, I would have just pre-drawn my circles. But when the day started, I'm like, Monday. Here we are on Monday again. And then later on, I'm like, well, hang on a second. See, I mentioned the compliance thing because I don't really want compliant students. Like the point of going to college and becoming educated is to ask questions. Like it is the most important thing now is to ask questions, and we don't prepare you for that by making you ask questions in high school. Do you know what I mean? The most important thing that you can do is question, especially people that are in authority like me. Question everything. Then also look in the mirror and question everything that you believe. And the more you believe it, the more it needs to be questioned. You know what I mean? The more you believe something, the more it needs to be questioned. Because if it won't stand up to questioning, if your beliefs don't stand up to questioning, that might mean that those beliefs have to go. Does that make sense? Never just believe people, especially me, because I'm in a position of authority. Spend all this time in college questioning the man, and then what happens? I'm the man. It's terrible. Just stick around long enough to become the villain. At least I wouldn't be a dumb villain like Thanos. People that say Thanos was right lack imagination. You know what I mean? I mean, he could like do anything because it's like the infinity gauntlet. Like he could do anything he wants. And instead of, I don't know, looking at saying that resources are a problem and just like making more resources. Snap your fingers, make more resources, dude. Then no one has to like disappear. You don't have to do a genocide. Or if you're worried that people are just going to burn through those resources, because spoiler alert, we would, like snap your fingers and make everybody, like, first of all, do two things because it's an infinity gauntlet. Make more resources and then make people use the resources wisely and share them. See, the reason that he wanted to snap half the universe out of existence is because he wanted to do that. He wanted to do a genocide. He wanted to kill people. It's not that he wanted to help. That was just his framework. That's how he justified it. And like when the whole universe is like trying to stop him, he doesn't stop and say, hey, maybe there's a better way. You know what I mean? All right. Let's talk about the angles that we need to know and the values that we need to associate with them. Starting with our quadrant angles, here's 0 degrees. And then the quadrant is 90 degrees. And let's see, the negative x-axis is over here at 180 degrees. And then down here at the negative y-axis, we're at 270 degrees. Each of these points has x and y coordinates. The x coordinate will tell us the cosine, the y coordinate will tell us the sine. So the coordinates at this point, 0 degrees, are 1, 0. The coordinates of this point up here at 90 degrees are 0, 1. The coordinates at 180 degrees, negative 1, 0. And the coordinates down here at 270 are 0, negative 1. Okay, and I just noticed the delay. Now I'm going to be distracted. Okay. That's going to make things way more difficult. I'm already struggling. I've got 2 delays going on. The processor in my brain and this one. All right. So this tells us 8 of the values that we want to know right away. Oh, wait. We get 2 for 1. Because 0 degrees is the same place as 360 degrees. So we get a couple for that one. From here, we can see that cosine of 0 is 1. I didn't want to use it for that. So from this point, we learn that cosine of 0 degrees is 1. Sine of 0 degrees is 0. Going up to that 90-degree angle, we get 2 more. We get cosine of 90 is 0. And sine of 90 is 1. Going around to 180. Cosine of 180 is negative 1. Sine of 180 is 0. Continuing around to 270, cosine of 270 is 0. Sine of 270 is negative 1. When we keep going back up to 360, cosine of 360 is back to 1. Sine of 360 is back to 0. Any questions? We want to see the patterns. We want to look for as many patterns as we can get. Notice that cosine starts off at 1, and then we go 1 down to 0, down to -1, back up to 0, back up to 1. So it starts off at 1, going around the circle. Starts off at 1, drops to 0, to -1, back up to 0, back up to 1. Sine starts off at 0 and heads up towards 1 first. Sine of 0 is 0. And the first quadrant goes up to 1, drops down to 0, goes -1, and then back up to 0. So we want to see cosine going from 1, 0, -1, 0, 1. Whereas sine goes 0, 1, 0, -1, 0. Up and down as we go round and round. Any questions? 30-degree reference angle. So if you want to draw a 30-degree reference angle, what we're going to do is go up half on the y and then straight across. And here we're going to be at a 30, theta equals 30 degrees. We need to be familiar with a 30-degree reference angle in all 4 quadrants. So if I take this half and go down over into the second quadrant, this angle also has a 30-degree reference angle. If I have a 30-degree reference angle, that is if the distance from the terminal side to the negative x-axis is 30 degrees, what angle are we looking at over here? I'll do the hard part. It's between 90 and 180, so it's 100 and something. 150. So 150 is a 30-degree reference angle in quadrant 2. If I go down to -1/2 on the y, cut over to the circle, and then back to the origin, that will give us a 30-degree reference angle in quadrant 3. 180 plus 30 is 210 degrees. And if I go down to -1/2 on the y, cut over to the circle, and then back to the origin, that's going to give me a 30-degree reference angle in quadrant 4. And that's 330 degrees. That was pulling out the 1/2 on the y-axis, the 30-degree reference angle. If we pick the 1/2 on the x-axis, that'll give us 60-degree reference angles. So if I go 1/2 on the x, take that up to the circle, and then back down to the origin. That'll give us a 60-degree reference angle. And I want to know a 60-degree reference angle in all 4 quadrants. So I'll take this 1/2 and I'll drop it down to the circle, then back up to the origin for a 60-degree reference angle in quadrant 4. And that's a 300-degree angle. If I go to where x is -1/2, bring that up to the circle, and then back to the origin, that will tell me my 60-degree reference angle That will show me my 60-degree reference angle in quadrant 2. And drop down to the circle and up to the origin in quadrant 3. There are our 60-degree reference angles. So that's going to happen at 120 and 240. And finally, I want a 45-degree reference angle in all 4 quadrants. So here you just start off at the middle and go up at a 45-degree angle. So notice that the 45 is halfway between 30 and 60. Halfway between 120 and 150 is 135. Halfway between 210 and 240 is 225. Halfway between 300 and 330 is 315. We want to know sine, cosine, and tangent of all these angles going all the way around the circle. Fortunately, since we have just 3 angles, 30, 45, and 60, the values for sine and cosine and tangent are going to be the same. The absolute values are going to be the same. We only have to worry about positives and negatives, but we also know what's positive where. Sine is positive in quadrants 1 and 2. Cosine is positive in quadrants 1 and 4. Tangent is positive in quadrants 1 and 3. Really driving me crazy because I could see it out of the corner of my eye, but then they. Any questions? So what we're trying to do is fill out a table where we know sine, cosine, and tangent of 0 degrees, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270. But wait, there's more, 300. Will it ever stop? 315. Please make it stop. 330. And 360. Back up here. No problem. 16 angles times 3, it's 48 numbers. But the values are all going to be from a limited choice because all the 30-degree angles will have the same sine. It's just going to be a plus or a minus. And the same cosine will just be a plus or a minus. And the same tangent, it'll just be a plus or a minus. We already know some of these. Sine of 0 is 0. Cosine of 0 is 1. Sine of 90 is 1, cosine of 90 is 0, sine of 180 is 0, cosine of 180 is -1, sine of 270 is -1, cosine of 270 is 0, and then 360 is the same as 0, same values as 0. All we have to do is fill in the rest of the table. Is everybody okay? This only seems like a lot to remember because it's a lot to remember. And we have to remember all of it all the time in perfect detail. So no problem. The advantage that we have is that there's a lot of pattern running around. And that's what we need to sort out. How we can find these values, what kind of pattern can we exploit? What are we going to notice for a pattern that we can exploit to learn all these values? This is like your trigonometry times tables. So way back when you were learning arithmetic, you just had to learn like 7 times 8 is 56. There are reasons that 7 times 8 is 56, but you just had to be prepared. Someone's going to say, hey, what's 7 times 8? And you had to know right away, it's 56. It's 56, right? Yeah. 14, 28, yeah. You just had to know that stuff. And then they started asking you variations on that. What's 56 divided by 7? And you had to know that that was 8. But when you learn 7 times 8 is 56, you were just told that, you were programmed with that piece of information. You just had to carry that around. Do they still do those mad minutes where you get one piece of paper and it has like 60 multiplication problems on it that are just one, like up to 12? You just have to just do them real fast. That's what we would do if I thought that was a good idea. I want you looking for the pattern going around these circles with sine, cosine, and sin. Any questions? Oh. Let's take a quick break of, let's go with 47 hours and come back on Thursday at 1 o'clock. Just a quick break, 47 hours. That's going to do it for today. Fill in this table and we'll go over the results on Thursday. That's going to do it for today. I will see you all on Thursday. Everybody have a good couple of days and thanks for playing. Try to stay cool.